This video clip is demonstrating the Pollux cluster-first system. Just as a recap, the computational pipeline here to generate this projection is we start with the set of weights, which at the moment are all initialized to 1, as well as the input data. Here are all of the dimensions that are a part of this data set. And we run a k-means clustering on it 1,000 times and take the best clustering result. This is the best clustering result that's generated. And then we take that and project it down into this 2D space using some selected set of edges. In this case, I have the centroids connected to each other and the centroids connected to the nodes within their cluster, as well as the nodes within the cluster are all connected. And so that means that the distance between clusters currently matters, and the distance internal to clusters matters. So two clusters that are closer together are more similar, two observations that are closer together are more similar. You can see that there's this details on demand interaction that pops up whenever I hover over one of the states to show what the exact data is for each one of these variables. So I want to replicate the usage case that was shown in chapters 7 and 8, and that usage case is trying to create a Midwestern states cluster. The goal is that this cluster here in the top left is going to be our Midwestern states cluster because it already has 7 of the 12 necessary states. And so the first interaction is to grab the state Ohio out of this kind of southern and middle eastern states cluster and pull it over into our Midwestern states. When I do so, you can see that, well, this cluster expanded a little bit because it got something new and unfamiliar introduced to it. And then all of the weights that are listed over here have updated. So because we're using a force-directed graph, the weights that are smaller have a greater impact on the clustering assignments, and the weights that are larger have less of an impact. And so, for example, the high school graduation rate is 0.456. This is something that's very important to this interaction that we just performed. And something that's not going to be so important is some larger value. So for one example, the area of the state, 1.324. is something that is not so important to this clustering assignment. Right now, Ohio is fixed in place. If I release it, it's going to get pushed toward the outside of the cluster because, well, we've only given it one interaction so far, and the system isn't quite sure how Ohio is supposed to fit into this best, so it's kind of pushed to the outside for the moment. But no other observations were reassigned to another cluster at this point. The second interaction is to grab Michigan and also bring Michigan up into this cluster. So when I do that, well, now two other things are going to get assigned. West Virginia gets pulled into this cluster of generally rural, low population density states, Maine and Arizona and Nevada and New Mexico. And then also Minnesota got pulled into our Midwestern states cluster, which again is something that we wanted to happen because, well, Minnesota is a Midwestern state. The system is starting to learn some of these commonalities between the Midwestern states and pulling states in that meet those commonalities. So I can release Michigan. Michigan gets pushed toward the outside. Ohio's starting to fit a little bit better in the rest of the cluster. We can move these states around a little bit and try to see just how best they fit inside of the projection. In this case, I tried to move Ohio up to see if it was related to anything Nebraska, Kansas, Oklahoma. It turns out it really isn't. It wants to be closer to Indiana and Michigan, which geographically makes sense. The next interaction is going to be pulling Illinois up into this cluster, and that's going to change a whole set of things. The important ones for this cluster here are it's going to grab Wisconsin and pull it into this cluster, which is something we want because Wisconsin is a Midwestern state. But it's also going to get Arkansas and Kentucky and pull those two states into this cluster. And, well, in the census definition, these are not part of the Midwestern states, and so we don't want them into the cluster. We'll have to remove them afterward. So I'll pull Illinois in. There's the big set of things that have changed. Wisconsin, Arkansas, and Kentucky all got pulled into the Midwestern cluster state. I'm going to release Illinois. Also, Rhode Island and West Virginia got pulled into our nice rural, low population states. Okay, so now we have all 12 of the Midwestern states in this cluster. 3 of them were pulled in by me directly, and the other 2 were ones that the system has learned. And so from here, we probably want to grab the states that don't belong and pull them out of the cluster. The states that don't belong are Montana, and Kentucky, and Arkansas, and Oklahoma. And so I'll start with Kentucky, because that was one of the most recent ones that got pulled in. When I remove Kentucky, Montana automatically gets removed. It gets pulled over into this more western states plus Vermont cluster, but we pulled in Tennessee. So Tennessee and Kentucky are pretty similar states geographically and demographically, and so Tennessee was probably something that was right on the edge of also getting pulled into this cluster before, and the slight change in weights for pulling Kentucky over into this cluster were just enough to happen to throw it over in this case. And so to continue this demo, I would need to pull Oklahoma out, pull Arkansas out, and also pull Tennessee out, and then we would have the full Midwestern states cluster.